And again, welcome to SMP's VMC on AWS webinar. This will be presented by Bob Elwertowski, SMP's Principal Architect. And with that, I will hand it over to you, Bob.
Thank you, Jennifer. As Jennifer mentioned, today I'm going to be talking about VMC on AWS or VMware Cloud on AWS. And knowing the audience is of varying calibers of expertise, what I ended up doing is trying to make sure that I've got a little bit in here for everybody. So from the technical side of things, we'll dig in and get, you'll be able to see a little bit deeper under the covers, and also making sure that I'm trying to set the framework a little bit so people that don't necessarily have as much exposure to VMC and AWS, they have a little better understanding when we're done with this. Hopefully there's a little something for everybody inside here. So the agenda, as you can see here, I'm gonna walk through a little bit of the what, when, and where, just to get you a little understanding around the platform. Then I'll dig into the architecture a little bit. So you're looking at some of the sizing and connectivity and the components. And then, we'll hit the how at the very end. I'll even say the why a little bit. I guess I'll say I'll go through why through the whole presentation a little bit. All right, and with that, I'll jump right in. So our clients want, they want the flexibility to consume resources wherever's required or wherever's needed, I'll say. So there's a few scenarios here that we've seen that VMC and AWS starts to make a whole lot of sense. And the first one here is to maintain their current data center footprint. Not everybody is like, oh, I got to get out of my data center completely and I want to move everything off site. Some people feel as though some of those critical applications need to stay on premises, or even, mandates from above are saying that they need to stay there. So some people, we're just going to maintain this data center. We've already got the investment there, and it's not a big lift to be able to maintain it. But to expand it, they don't necessarily want to do that. So this is where they want to expand into the public cloud and be able to leverage resources very similar to the ones that they would have on premises. And we see a lot of times people doing this when they want to push test dev out of the environment and use that in a different environment where we have the ability to expand very easily, and then possibly pull them back on site after the fact. Another scenario is to actually consolidate, and that's exact what I was alluding to on the first one. Was I don't want to be in the data center business anymore, where this is aged out and I no longer want to maintain this hardware. I just want to get out of the data center side of the hardware component and move everything right into the public space. So you want to consolidate that data center and, application migrations across that link right into a cloud platform. Another common scenario is, I want that flexibility and agility. I want to be able to have everything that I need both on premises, or either on premises or in the cloud. So as I was saying before, the test dev type environment where I want to keep it on one side, or I want to do it on one side and then pull it back in and run it on the other, or flex to be able to go across both of them depending upon workload demands. All three of these become very common, and the common theme that you're going to see is you get to decide where you want to put those things, and what does that actually start to step. It starts to step you in the direction of the hybrid cloud. Okay, that's really the end state, I'm going to say, for organizations. They need to be able to walk down this path to be able to maintain relevancy inside of the spaces that they compete today. So I'm going to touch on these 5 challenges and complexities that you're actually going to see, or typically see. So the operational inconsistencies. We don't have the same tools. We're not using the same things. It makes things a little difficult while we're trying to do that. All right, or whether it's that or the incompatible machine formats. When you're looking at those incompatible machine formats, you're like, wait a minute, on premises, I've got a virtual machine with a VMDK, and then I go into AWS and I've got an AMI instance, and how do these blend, and how do I convert from one to the other efficiently and in a timely manner? And then, like as I was saying, some of those management tools and the security control. So how am I controlling the security of being on premises versus being in this cloud? Because they are not necessarily the same in all situations. So these are, like I said, 5 components that we are typically seeing people run into. And I'll say that the one thing behind VMC and AWS is it actually starts to break down some of those barriers that you're typically seeing inside of those 5 things that I called out already. And what we're going to do is through this presentation, you're going to see where I'm going to help get through these barriers, as you see here, to understand how, and then I'll recap for you, where they all stand. So let's start off with, where the real power is inside of VMC and AWS. So it's the typical components that you're seeing inside of your environment today. All right, so it's the vSphere environment that 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 owns most of the market share, that we've all become to know and love and feel as though it's the staple of our data centers as they are today. And then you have vSAN from the storage perspective. It's an all-flash configuration with replication all built in, and it's simple, cost-effective, enterprise-grade storage inside of that platform. And then you have NSX. And that's going to help you. And I will say that, a lot of the times the magic is in the network. How are we actually getting through down these paths? How are we getting the bits from each location? How are we getting through some of those challenges? And I'll say that NSX happens to be the secret sauce here that's going to enable that a lot. And it still brings that, so you can have those stretched networks from on-premises to into the cloud, and still maintain that microsegmentation and the advanced layer 4 and layer 7 services that become a requirement when you start to look at the security behind our current data centers. So VMware Cloud and AWS is a service. Let's just make sure that that's understood. It's jointly engineered with AWS, and it leverages the AWS infrastructure, but it is a service delivered by VMware. Everything rolls through VMware to be able to do this. So let's double click a little bit down and see what that means. So, the as a service model, VMware manages the hypervisors and the management components. AWS has all of the hardware, and then you end up managing all of your workloads. All right. So when you look at it, you don't have any, no ESXi root access. So you can't add any VIBs or anything like that to be able to make any changes. But you will still own all of the, you can still do the configurations. You just don't have the root type access. So to be able to add for your compute workloads, all of those are completely compatible, and you have the ability to make the changes required to control your traffic inside, your traffic and your resources inside the environment. So here's what I'm going to roll into the architecture a little bit. All right, just so you can see. So what is it? As I said, it's AWS's global infrastructure. All right, so we're going to take AWS's global infrastructure, and then we're going to lay those 3 components on top of that global infrastructure that I told you. So we're going to take their bare metal instances, and we're going to install Virtual Center with vSphere and vSAN and NSX all inside it. And as it says, this is all on bare metal. There's no virtualization. I know when I first heard it, in the beginning, I thought it was nested sessions and all that, and I was like, that's going to be terrible. But obviously, I was wrong, and it is all bare metal and very performant actually. So what we do is then we take your current environment, where you are today, your data center, and we link together those virtual centers. So now you've got a single management plane for both your private on-premises data center and your VMC and AWS data center. With that, you can lay all your management components on top of it, or any of the infrastructure pieces that you need, whether it's containers or any of the ecosystem partners if it's supported on premises, chances are it's going to be supported on top of VMC and AWS, as long as you don't need to tie any VIBs in. All right, and then where the real power of this to me is, because this is, having your workload in the cloud isn't necessarily as big of an option, because there are other pieces of the puzzle if you were all to roll all in that. But what's nice is to be able to have that with your same management controls, and then be able to leverage, or expand the AWS global infrastructure and leverage all the AWS services. Things like, if you need an EC2 instance, or you need the S3, or you want to leverage Lambda, or RDS or any of the pieces inside of AWS that you're looking to try and leverage, you have that capability. It's all, it's all pinned in through an ENI that connects those together. So you have a zero cost associated or a zero network bandwidth charge to be able to pull those services in. And now you've put your workload a lot closer to those services. So you have the ability to start to migrate from the traditional 3-tier application maybe to a cloud native application that is going to be a little more friendly from a resiliency perspective. It's going to provide you that agility that you're looking for and burst a lot easier than saying, oh, I got to add some more CPUs or I got to add some more disk to this this application. It's a lot more intelligent when you start to look at the cloud native stance of applications, which is why there's such a demand behind them today. So let's look a little more with the integrations with AWS, as I was saying. So you're going to have your VMware Cloud on AWS account is going to be the one on the left. All right. So you're going to see the components inside there, ESXi, vSAN, NSX, and your client gateway. Those are the pieces, or your compute gateway. And so those are the pieces that you end up leveraging while you're inside of that. All right, and then you have your client-owned AWS account. So if you have that account and you want to be able to use, an EC2 instance or some S3, you've got that ENI that I said you're going to leverage, or obviously it's anything inside the AWS catalog you can actually leverage inside of your VMC and AWS instance. All right, so one good example that I look at here all the time is one current on-premises challenge that we run into is where am I going to put my backups, or where do I write my backups today? So you've got something like we'll just say you're running Veeam with data domain or Exagrid or something like that. So you've got this infrastructure that's sitting there that you're running your backups on. So in this situation here, you can literally just write your backups across that ENI to an S3 bucket. So now you're starting to separate out those workloads, and it is separate infrastructure. It's not the same infrastructure. So that gives you that capability to do that, and then you can replicate that S3 bucket to a different availability zone or a different region inside of AWS. There is some costs associated with doing the replication to different regions, just to make sure that you're aware of that. But at least it gives you that capability to get it outside of the current storage platform that you're using for production. So how does the accounts work? All right, so you're the VMware Cloud SDDC account, and then there's the AWS customer account. So your SDDC account is what's going to be created when we first do the instantiation of VMC and AWS. This is owned and operated and paid for all by VMware. VMware is the owner. Each account is a single tenant, and you will have no other people inside of that account with you. It's just your account. The AWS account is going to be owned, operated, and paid for by you. You own all of the components to it, and you'll be the one that has to ensure that there's a payment associated with that. So you have that private connectivity and has full access to the full catalog of native AWS services, as I mentioned before. So as I said, not everybody has got the same level of knowledge around this. So sometimes a picture, and you're going to see I'm going to do this a lot, talk about it a little bit, and then show you a picture so you can see a little bit what this looks like. So as you can see here, from the who controls what standpoint, you'll see Virtual Center, NSX, and the Platform Services Controller are all controlled by VMware. VMware does all of your upgrades. Okay, so you never have to worry about when am I going to do my vSphere? When am I going to call SMP and say, can you come do my vSphere upgrade? Or when am I going to schedule my weekend and say, here, or during the weekday or whenever it may be, and check the compatibility matrices and do all of that stuff to make sure that your hardware components are going to work. You don't have to do that anymore. They automatically take care of all of the all of the upgrades for you as they come out and become available. So you're always up to the, actually it's kind of funny. It's actually versions before what you can actually have on premises. Okay, and then as I stated before, you are the one that manages and owns the virtual machines in the green here on the right. So the cloud configuration, and so there's 2 SDDCs per organization where you can have up to 20 vSphere clusters per SDDC with 3 to 16 hosts per cluster. So as you can see, this can get you can get very large inside these configuration. And the important bit to understand here is you don't have all of the additional management overhead. The only management is in the first cluster. So everything after that, it leverages the same management cluster, and they just become workload domains associated with that. So now I'm going to double click a little bit inside of the compute options. All right, so we've got the i3 Metal, and as you see here, that's the AWS name. So if you go to AWS right now and you were looking i3.metal, that is I'm going to call it a SKU inside of AWS. So you can actually absolutely do that. You could use this for whatever you wanted to, install Windows on it if you wanted to just go down that path. But this is the hardware that's actually being used. So when you look at the 3-node cluster, 3 node is the minimum that you can have, is you're going to end up with 108 cores and 1.5 TB of memory. And you saw this goes up to 16 nodes, and in a 16 node configuration, you're going to end up with 576 cores and 8 TB of memory associated with it. Now the hardware, inside that it is an Intel E5 2686 version 4. It's 18 cores with a 2.3 gig processor. Hyperthreading is disabled, and it's disabled for security reasons. And they all have 512 gigs of memory in each one of those hosts. The next one is the R5 Metal. Nope, just kidding. They just discontinued that one like I think 2 weeks ago, 2 weeks ago, something like that. They just discontinued it. What this was a node that it was an R5 Metal node that we were using EBS backed storage instead of having the onboard SSDs. All right, but you can no longer get this one. So what they replaced it with was the i3 Metal. All right, so you can see here that you're going to end up with a 288 cores and a little over 2 TB of memory associated with a 3-node cluster, going all the way up to 1536 and 12 TB of memory in a 16-node cluster. These are dual socket platinum boxes, 8175, so that's 24 cores at 2.5 gigahertz. Hyperthreading is enabled on these because it's a newer proc, so it doesn't have the same security vulnerabilities. And there's 768 gigs of memory per host. I will say that typically from what I've seen so far, a lot of times, and I'm sure you're all well aware of this, that these are not typically the bottlenecks that we usually see. Usually we end up seeing bottlenecks in the storage arena. So I'm going to get into that in a little bit, but this is a pretty good footprint. So understand, as long as you understand where your workload is and understand that it is burstable. So you can start out with a smaller, add a node for 2 days and pull it back, or a week or 2 weeks or a month or however long you want. There's 3 different ways to be able to add nodes to your environment. One is on demand. They will charge you as long as you have it. They will charge you a certain rate. And then they have a 1-year and a 3-year reserved instance. If you're familiar with AWS, that's a very common terminology, the reserved instances. So they give you discounts based on guaranteeing a 1-year and 3-year usage of that hardware. So you will see that there are some discounts to be able to leverage if you're doing it. But it's nice to have the ability to flex and just say, I just need this for a little while and come back. So think of it from a DR perspective. You have just enough, you have the footprint to keep the pilot light, so to speak, on. And then when you initiate a DR, you stand it up and you're like, okay, now I don't have enough compute and memory sitting here, but I got all the storage that I need. So you start to roll in additional nodes to give you that CPU and memory that you might need to be able to run all of your workloads in totality in the event of a DR. So and it's really nice from doing a testing situation and all of that. So you just stand up extras for doing testing and then roll them back out when you're done with your DR test. All right, so how are they offered? So you've got your regular cluster from 3 to 16 nodes restricted to a single region and AZ. So you can't go into a region and separate them in different AZs inside that region. Obviously, if for some reason that AZ went down, if you didn't have enough, your faults to tolerate would probably not sustain you to be able to keep all your workloads up and running. So that's why they tied to that. However, you have that stretch cluster. So in a stretch cluster, now I can stay in the same region, but I can go across availability zones. So now that I'm going across availability zones, they have the ability to you have the ability to lose a whole availability zone and still not be impacted. And they provide you with that 0 RPO and the RTO of just an HA restart, which, as we all know, inside of a VMware environment, a restart usually can happen pretty quickly. So here's what that picture would look like. Both of them inside of one region inside of one availability zone, and then you'll see the 2 availability zones on the right-hand side, all sitting on top of, obviously, that AWS global infrastructure. So now, as I said, storage tends to be a little bit more of the bottleneck most of the times inside of typical environments. So we'll dig into this a little bit. So keep in mind that vSAN is completely FIPS, vSAN is FIPS 140-2 compliant, and they do use the AWS KMS, so you don't have to worry about how am I going to handle the KMS side of things. So you do have all of the built-in encryption and to be able to meet any compliances that you may have. All right, so as we were talking, you got the i3 Metal, and what that is, it does have 8 self-encrypting drives. It gives you 1.9 terabyte drives. There's 10.2 terabytes of raw capacity per host. You do have the capabilities of RAID 1, 5, and 6, and automatically enabled is encryption, deduplication, and compression. So where do you fall from a usability standpoint? Obviously, some of this is your mileage will vary because what am I getting for deduplicate compression ratios, and how does that fall? But typically, this is where we're seeing from a usable standpoint. Obviously, FTT0, I kind of laugh that this is on the screen a little bit because nobody's usually going to do that because any failure would cause data loss or unavailability. So typically, you obviously wouldn't see that. You would see something around the FTT1 or FTT2 per node, or RAID 5 and RAID 6 obviously can be a little more friendly from the amount of data to sit on each one of these nodes. So as long as you've got the number of nodes required to hit the RAID 5 and RAID 6 requirements, then you're good. The ENs. So the ENs that just dropped, they're very similar from a configuration. It's 8 drives, 7.3 terabytes, which that gives you 41.4 terabytes of raw capacity with the same configuration parameters. So as you can see, both of them are 2 disk group configurations. So you'll see here, you've got 2 cache drives and you've got 6 capacity drives behind it, 3 on each one of those cache drives. This is going to improve your performance with parallelism, as well as prevent against any failures that might happen while you're there. It has less of an impact from the data. And then, these obviously are significantly larger, so you can have a much greater footprint or a much greater data density inside of a footprint. When you're looking at something from, I guess a full FTT to 2, if you had enough at 10 terabytes all the way up to, 32 terabytes available inside of a RAID 5 erasure coding position. So another thing to be very cognizant of is it's a public roadmap. So as you can see here, this one here obviously was just from May, but it gives you the ability to see what's coming, what's available, and as I said, it's always changing. So it is something to be very mindful of as you're planning your path through this. So from a networking configuration. So as I said, I'm going to move into the networking a little bit, and this one here is where you're going to see some of the explanations and then some pictures to try and help visualize it a little bit better. because networking is the place that's probably going to get a little more sticky. The other ones are kind of straightforward from a CPU and memory building block perspective. Networking has a lot of different options that you can use. So let's start with the kind of the foundation. You know, you've got your management pool and your compute pools. So that gives you two different paths. All right, so you've got your management gateway where your virtual center, PSC and NSX manager are sitting behind that gateway. And then you've got your compute gateway on the other side that all of the virtual machine, all of your client traffic is going to go through that one. It tends to, you know, give you better separation and control behind the environment, and keeping all, you know, all the firewalling and security associated with each one of these paths complete. So what are some of the options? So as you can see here, depending upon where you are and where you want to be a little bit, you know, the bottom left is the customer data center. So that's your on-premise location. The top is your AWS account. And then the bottom right is the VMware, VMC, and AWS SD account. So you'll see that there's multiple different ways to be able to connect these together. You know, obviously the ENIs is probably the best to go from the customer-owned AWS account to the VMware VMC on AWS account is the ENI due to the costing and speed associated with it. And then as to how do you get to your data center from those two accounts, you know, there's several different ways depending upon what components you have available to you. But what I'm seeing in the conversations that we have, Direct Connect is generally your best path down this, depending upon what you're going to do. We're having a lot of conversations around cloud adjacency, where it probably would make sense to definitely look at some of those. And I'd be glad to have a conversation with you around cloud adjacency at another time as well. Just reach out to your account managers. All right, so here's where we're gonna, you know, look a little deeper underneath the covers here. So if you take your VMware Cloud and AWS data center, you can see the three. So you've got your IPsec VPN to any existing network architecture. You've got a layer 2 VPN, fully NSX. So it's really nice from a full NSX deployed on premises. You can connect back into that. And the other side is the Direct Connect, like I said. So that's the path that we're seeing leveraged the most is the Direct Connect, because this gives you the fastest connection, and you can also stretch your NSX policy. So if you're running NSX on site today, you can drag those right inside the VMC and AWS to ensure that you're keeping that security posture that you've already got and understand inside your current environment. As if you feel back to the first couple slides when I was talking about some of the barriers or some of the issues that we see, you know, that's one way to be able to keep that security posture in place. So this is what it can look like. So you'll see here your management gateway is on the bottom in the blue. All right, and then you can see where it's firewalled out to the internet. And then you can have different compute pools that go through your compute gateway that will get you that they're, you know, completely separate streams of traffic that will go out and out to the internet. Obviously, the picture's a little misleading here because the compute gateway does not go back through the management gateway, just the way that the diagram was pulled together. But this gives you a good understanding from the features and where things are actually standing inside the stack. So the networking, you know, the hybrid networking is really, you know, keep in mind everything inside of VMC and AWS is NSX. So, or well, I guess I should be more specific in NSXT. So you do get that firewalling, VPN, microseg, you know, all the things that people have become to know and love associated with NSX. And then you have that connectivity with the Direct Connect IPsec VPN or the AWS VPN. And as you can see here in the picture, you know, I wanted to make sure that you got a little bit of the understanding of what's inside the GUI, and it becomes very easy to understand where things are and how things are connected back and forth. So you can see here the VPC and how it's connected back out to the internet with the on-prem and back to on-prem. So NSX and the AWS Connected VPC. So here, what this is going to give you a little bit of your, on the left-hand side is your AWS VPC. Okay, so on the right, inside the white box, is what your VMC and AWS is going to look like. So obviously, it's still in one availability zone, and the green is the management components that you do not have access to, and the blue is the NSX overlay that you do have all the access to be able to have any of the subnets that you require for any of your virtual machines to be able to push out through the internet gateway. If this one here is talking about connecting straight back to another VPC. So obviously they're going to use that ENI to be able to get you back out so you can connect to that S3 bucket or to those EC2 instances, or as I mentioned before, any other component that's required inside of the AWS services catalog. But as you can see here, IPs are not necessarily an issue. They all start to get masked through what NSX can provide. And here's that Direct Connect that I was talking about. So when you're looking at the Direct Connect, all right, your data center will be on the left-hand side. VMC and AWS data center is on the right-hand side, all right? So that Direct Connect location in the center is going to be something like an Equinix data center, all right? So you might have CenturyLink get your data from your data center in your on-premises data center to that Direct Connect location. At that point, all it is a router, and you have a router inside of your Direct Connect location, and then you plug that in. They basically take a cable and plug from one router into the other router. So you are right on net at that point with AWS. So from that Direct Connect location to VMC and AWS, you're now riding that AWS backbone to be able to get that data in. And this example that's sitting here is a private VIF, so that pushes all that traffic right through the environment. So like you saw before, it gives you the highest speed and the easiest access to the environment to be able to get all that data across, up to 10 gigs that can be dialable depending upon how you're doing this. So spin something up, we're migrating our data centers, spin it back down to a 1 gig connection, or less. So you don't have to worry about, this is what I need from a billing. So you don't have to worry about the billing, because obviously AWS, or any public cloud for that matter, is all about consumption. We're going to charge you for consumption. If you're using it, great. If you're not using it, we're not going to charge you for it. But if you've provisioned it and you're not using it, we're still going to charge you for it. So you got to be a little mindful on how you are looking at some of those knobs. But as you can see inside the VMC and AWS stack, you can see you still got your distributed logical router sitting there, so with your NSX overlay. Okay, here's a nice example of some of the things you can do when you start looking at that Direct Connect, because as you can see, the Direct Connect is right in the center. But what's nice is it gives you the ability to have your VLANs advertised via EBGP, sorry. So you can see whatever traffic is in your on-premises data center to your VMC and AWS. So it makes it, from a routing perspective, it starts to make it really smooth. You don't have to worry about, I have to be concerned about any hops in the middle, or how am I routing and which way am I pushing traffic and all that. EBGP starts to take care of that for you. And gives you, so you can see here a little bit how they're actually pushing their VLAN across the environment and what the interfaces are and all of that. As I said, some of this is a little deeper for some of the people that are on the call. We'll also make sure that we get you the deck, so you don't have to worry about trying to taking notes or copywriting any of this stuff down. Some of it gets a little detailed. We'll make sure that we send this to you as well, so you have this for a reference. So I've gone into a little bit of what it is from an architecture perspective, the connectivities, how am I sizing it, what are the options that I have from a component perspective. Let's look a little bit at some of the use cases that are available, so you understand basically the why, or where would I use some of this. So as I stated a little bit in the beginning, the data center extension. So this would be that whole footprint expansion, the on-demand capacity. The on-demand capacity is a thing that's really advantageous for a lot of people. You know, you don't have that capability inside of a data center on-prem. You have to buy the hardware, buy the licensing, buy everything associated with it, and then it's capacity that's sitting there, whether you use it or whether you don't, you've already paid for it. Where, you know, that on-demand is really kind of nice to be able to use it for a little while and then shut it back off. So that, and you know, test dev can obviously fit right nicely inside of there. Disaster recovery. So disaster recovery can be leveraged in a few ways, whether it's a new DR approach, whether it's replacing an existing DR, or even complementing an existing DR. So if you've already got DR, but maybe it's not big enough, or I've got DR, but I want to have it in different zones, or whatever, however you want to handle things, and I'll dig into that a little bit further in a minute. Or cloud migrations. So, you know, application specific or data center wide, you know, or infrastructure refresh. You know, again, so this would be that whole, you know, kind of getting rid of the data centers and moving right into the cloud, and just the cloud. And then application modernization. So as I was saying before, this gets you that one step closer. And in this case, you're sitting inside of AWS's data center, so you're right next to some of them services. So to be cloud native or next generation applications, you know, it's about services. It's not necessarily about servers. And it's a paradigm shift that takes a little bit to get through. So you have to understand the refactoring, replatforming, and understanding how you're going to get there. So it takes some time, but having the data as close as you can to the infrastructure is going to make that easier. So, you know, any of the application modernization initiatives that you may have, this is a good step to be able to get you down that path and to be able to leverage that emerging technologies that, you know, all that the cloud providers are bringing as a service. So I'm going to click a little bit inside of the site recovery one, or the disaster recovery use case that I was talking about. So Site Recovery Manager has as people may be aware of, is a VMware product, and this is which actually, you know, it's checkbox configuration. I mean, a little more than that, but it's really check the box that yes, I want to use Site Recovery Manager, and it starts the process for you. But it's basically all of the Site Recovery Manager capabilities started to roll back in here. So you accelerate the time to production. So when you have an outage for some reason, this is an automated fashion to be able to get you back up. You know, you have no application conversions. Everything's ready to go. You know, as I said before, you got that pilot-like capability inside of VMC and AWS. It simplifies your disaster recovery because, as I said, it's all automated, it's orchestrated, it's all the familiar tools that you're used to working with. It's not like I'm saying, okay, before I was looking at my, you know, my storage array sitting over here, or I was looking at my vSphere environment in my production environment, and then I go to AWS or any one of the hyperscalers and say, okay, now I've got to worry about AMI instances and how am I getting my storage and where's the data refreshing and how am I doing the conversion from VMDK to the AMI format. You know, I mean, all of these things start to unravel. And you know, as somebody who's been in a DR situation before, the last thing that you want is complexity. You want it to be as simple and orchestrated and automated as you can have. Understanding all of the automation and orchestration is a requirement, but you want that to be done because it's a high stress and everybody comes looking for because their service is most important no matter what it is. And then, you know, again, it's a cloud economics, as I was saying before. You know, it's on demand, so you're only paying for it when you're using it. And it's managed. So just think about, as I said, I don't have to worry about doing those upgrades all the time because you don't have to have the same version of vSphere on premises that I have in VMC and AWS. They are interchangeable, so you have the ability to have that always updated for you. So what does it look like a little bit from a picture perspective? So when you want to replace an existing data center, you know, so you can see here the left-hand side is your on-premises data center. and you have an existing on-premises data center that you want to deprecate because you no longer use that, you can then just move that workload right into VMC and AWS. All right. The same thing can happen here. You could, as I was stating, you can use it to complement your existing one. So I can still do automation. I can still leverage SRM to go from data center to data center, but I can also use it to go from data center to VMC and AWS, depending upon the workloads, depending upon priorities. I might want all my Pri 1 stuff to go on premises and everything else to go to VMC and AWS, or vice versa. All my Pri 1 goes to VMC and AWS, and all the other stuff just goes to the other data center, because we all know that DR just gets the old production environment. So performance could be an issue. Or there's cases where some people don't have a DR strategy, and this gives you the ability to actually have one. You know, where I could just stand up a net new greenfield deployment right from our current environment right into a VMC and AWS. And I would say that you can also do the other thing and go from currently on VMC and AWS as my production environment and go to a different VMC and AWS instance in a different region. So I could go from Virginia to Oregon. You know what I mean? So I could have that as my 2 points of disaster, or I should say protected and recovery locations, however you want to have it. You could go back and forth between one and the other, and have, you know what, if for some reason I think AWS is getting shaky and I want to be able to pull it back down, so maybe my business critical applications come back down on premises. You know, so either one of those will actually work. So what does it end to be? As I stated before, this is, you know, site recovery manager. So it is, you know, it's non-disruptive testing. So I can stand up the environment inside of VMC and AWS. I can test everything that I need to test, and then have it not impact any of my production. I got automated failover. So it's push of a button, fail my environment to VMC and AWS, or to another instance inside of VMC and AWS. However you want to do it, it's literally a single click. You push the big red button as the joke. And then you've got automated fail back. So it's going to reprotect the original, whatever it was originally, and it automatically does the bidirectional migrations. All right. And then the detailed reporting. So detailed reporting is really important, especially in compliancy situations, when you can walk over and say, here, I can click this button and my DR plan actually prints out in its most current state. As I said, I've been in DR situations, and you go to the DR documentation and it's 6 months old on a good day, you know, because we all know, IT documentation is the last thing that we do ever because we hate it. So nobody's doing any documentation, and then when somebody comes in for an audit or whatever, you say here, and they're like, yeah, this is old. These all versions are incorrect, and runbooks are out of date, and all of that stuff. So this gives you that ability to have that and very easy to audit and say, wait, maybe we need to flip this or change this situation because of, you know, boot up priorities or whatever it may be. So I've thrown a lot out there, you know. So how do we get here? How do we get there? It looks a little scary at times. It's not as bad as it seems. Okay, you know, workload mobility is really the critical component here. You know, obviously everybody wants to be able to move a workload from one side to the other, and that's really, as I said before, a hybrid cloud. So you really want to be able to do that. So all you need to do is have that hybrid link mode set. Once that hybrid link mode is set in place, it unlocks a bunch of doors. So I can use, so there's 3 different tools: VMware hybrid extension, live migrations, and our cold migration. Those are 3 different paths that we can use to be able to get that data from one side to the other, or from one cloud to another. Because yes, this is VMC and AWS, but we also have VMC on Google and VMC on Azure, and, you know, all of them you can push, you know, VMware stance, any workload in any cloud, it doesn't matter. You know, because you do still have the content library that will get replicated, and enhancing motion compatibility lines everything across the bucket. So that's what starts to make some of this stuff work. So from a live migration, this is vMotion. You know, this is, you know, VMware 101. as long as all the networking is piped across, so we don't have to worry about IPs, you can dump that data right across one at a time, nice and easy, you know, and not have any issues. Some of the things that you have to be very mindful of are you have to make sure that you're 5.5 plus to be able to make this work. Otherwise, obviously, some of these things are going to fail. You know, some of the places you were looking to do this is some burst requirements or disaster avoidance or any of that stuff to be able to say, here, I'm just going to move some of these workloads over, spread things around a little bit. So, you know, like I said, the VM remains powered on, so you never lose anything. Some of the source and destination, the bandwidth, 250 megabits per second, and the latency, a round trip latency, it has to be under 100 milliseconds, or 100 milliseconds. All right. And then from a networking, you have to make sure you've got some of those networking components in place and have the proper versions of them. EVC considerations is obviously a must. Make sure that they're both turned on to be able to make sure you don't have that issue, because they do per VM EVC considerations. Compatibility version 9, VM compatibility version 9 is a requirement. You know, there's no big lift here to be able to make this work. The big brother, I'm going to say, is the vMotion with vSphere replication. This lets you basically, it seeds everything across from one side to the other. So then when you do the migrations, it's only moving key objects at that point in time because it's already got a copy over there. It's just adjusting pointers to be able to, and refreshing data as it pushes over. So it's a much quicker, easier move. Migration supported from vSphere 5.0 and on. Cold migrations. So this is where you're going to have to make sure that that VM is powered off. It can't be on. You do have some pieces of the puzzle have to be there. You'll notice on-prem vSphere versions 6.5 or later, and 6.0 update 3 or later. Some of the firewall rules, you know, on-prem and cloud SDVC, we have to make sure are in alignment, and in the switches that are required. But this is, you know, this basically is going to, you got to power off your virtual machine. So depending upon the size, it can be invasive. So it's not something that is used a lot, but it is understand that there's reasons behind all of these. So it's just a different tool in your toolbox. I will say the most desired path though is VMware Hybrid Cloud Extension. So this goes any to any to make everything easier for you to be able to move those workloads. You know, on premises can be version 5, and where it's going can be any version that you want. So, and doesn't matter whether I'm moving it to a different data center, VMC and AWS as partners. It doesn't, you know, as long as the vSphere environment's sitting there, it'll swing them over and it'll drop it there. So it's really good for, I'm just going to use the term bulk or mass migrations or mass move. So like DC evacuations, consolidations, you know, hardware refresh. I want to move the data over there so it can keep running, do everything I have here, and move everything back, depending upon what it is. But this is really a much better approach to be able to do that migration. It's you know, as Staples would say, it's the easy button associated with doing those migrations. And as I said, here's a picture. It shows you a little bit of how it's actually doing those migrations back and forth, and what, you know, what the requirements are associated with it. As I said, I'm not, you know, I don't expect you to take any notes off of it because you'll be getting the slide. And I got a shout out to Ahmad Yunus. He's the one that actually created that slide. He did an amazing job with some of the things that he actually pulled in here. It's another thing that we'll make sure that you have is the VMC on AWS poster that Ahmad actually created, and you'll see some of this is pulled from there. So the transform business, you know, when you start looking at that hybrid cloud, you know, I told you I was going to circle back and start to look at some of the components that were some of the biggest challenges associated here. So the incompatible machine formats, you know, these are leveraging VMware standard machine formats. There's no difference. There's no changing. None of that. It's all exactly what you're using today. Different skill sets and tools. It's the same VMware skill sets. And you've got that simplified workload mobility. So I can move things around them wherever's required. disparate management tools and security controls. It's the same VMware management. There's no changing. All the tools that you use on-prem, you can use inside of VMC and AWS. And it's got integrated VMware security controls because, as I said, I can stretch those NSX firewall policies to help pull you right in. And the software is always up to date. So I don't have to worry about, there's a security vulnerability. We got to make sure that that gets patched. It's automatically getting patched. I don't have to sweat it. Inconsistent application SLAs. It's predictable performance. We understand where the metrics are going to be, and it's easily mobile, and it's a fast. So if I don't have the resource required, I can increase those resources within 5 minutes. So it really starts to make it really easy to ensure that you do have that application SLAs. And when you start pinning all 4 of those together to the last one, which is operational inconsistencies, again, as I said, it's all the same that you've already been used to, and it's all consumed as a service. So you don't have to necessarily worry about where everything is standing. It's there, so when it's consumed as a service, it's naturally going to remove or reduce your operational efficiencies, or I'm sorry, improve your operational efficiencies. So, this is where everybody wants. The destination is the hybrid cloud. The first steps are to start going down the path of something like a VMC and AWS to be able to get you down to leveraging the hyperscaler services that are available from each one of them. I'll continue down the AWS one. So if you wanted to leverage something like S3 or Lambda, or looking at those functions or those serverless functions, it really starts to make things almost a no-brainer and a required first step. So how can SMP help? There's 2 procurement options. One is through credits or MSP. SMP can do both of those. So if you want to just grab some credits and say, here, I want to do a 1-year reserved instance of 3 nodes. We give you a quote, here's some credits. We'll help you get down the path of deployed, and then you go ahead and do whatever you would like to do with it. The other side is the MSP. Some of the big difference here is how you want to pay. Do you want to pay monthly? Do you want to pay all up in front from a credits perspective? And then in an MSP, we are your first line of defense. We'll take all your calls. You're calling into our smart center, which is headquartered right in Rochester. So it's manned 24/7, 365. And where do our expertise fall? We can assess, design, deploy, and support the full VMC and AWS stack. And with that, I will say thank you.